In this example, we'll need to algebraically determine two consecutive whole numbers such that the sum of their squares is 265. So what's important to remember here is that we're talking about the sum of two consecutive whole numbers. So that implies that we can't have any decimals, and it also implies that we can't have negative numbers. Because remember, your number system, whole numbers do not include the negatives. That would have to be the integers. So we're looking for the sum of their squares to be 265. So when I'm thinking about consecutive numbers, I first want to define what my starting point is going to be. My starting point here for a number could be n. If I think about a number patterns, like 1, 2, 3, 4, and so on, consecutive numbers means one comes after the other. So if I want to get from 1 to 2, I need to add 1. If I want to get from 2 to 3, I need to add 1. If I want to get from 3 to 4, I need to add 1, and so on. So the next number after n, or the next consecutive one, would be n plus 1. So my two numbers here would be n and n plus 1. Now the next part of the question says that the sum of their squares is 265. Well, the square of n would be n squared, and the square of n plus 1 would be n plus 1 squared. And it says that the sum of these two squares should be equal to 265. So I'm beginning to arrive at some type of quadratic relation, but if I want to be able to solve it, again, remember, we need to have this equal to 0. So I'll need to take this part now, n plus 1, and FOIL that out. So that would give me n squared plus 2n plus 1 inside that bracket. And that's equal to 265. So I have n squared and n squared gives me 2n squared plus 2n. And bringing the 265 over, minus 264. Before I do anything else, I notice that all of these would be divisible by 2, since they're all even numbers. Dividing all by 2, my 2's cancel there. And I have n squared plus n is equal to a negative 132. Looking at this now, I see that the value in front of n squared is equal to 1. So there's a good chance I could factor this using product and sum. So I'm going to go ahead and try that. So I'm looking for two numbers that multiply to give me 132 negative, but that add to give me positive 1. So again, multiply to give me negative 132, but that add to give me a positive 1. Well, I know 11 times 11 is 121, and I know 12 times 12 is 144. So trying 11 times 12, that gives me an answer of negative 132. And if I want it to be a positive 1, that means the negative needs to go on the 11. So that tells me I've got n minus 11 and n plus 12 equal to 0. But I need to further go ahead and solve this. So using the zero product property, I set both equal to 0. Giving me answers of n equals 11 or n equals negative 12. Now reading the problem, it did say that they're two consecutive whole numbers, so I cannot use negative numbers in this example. So I need to reject the negative 12, which means that if n is equal to 11, then my solution states that my first number is 11 and my second number is 12. And if I add 11 squared and 12 squared, I will get 265.